Hey, this is Mr. Mitchell with another video. Go ahead and write down these questions and you can find the answers in the video. Today we're going to be talking about changes of state, like going from a solid to a liquid to a gas. Now, we're not going to deal with plasma on this one, just the three that you commonly find here on Earth. And all of these changes of state are physical changes. You do not have a chemical change whenever you go from ice, for example, to water, for example, to water vapor. The changes do not alter the H2O chemically. All of these three are H2Os, regardless of what state it is in. But what it does alter is the spacing of the molecules, the arrangement of the molecules and the space between them. And that is the difference between ice, water, and vapor. It's how much space is between each molecule. Well, let's talk about melting. Melting is the process by which a solid becomes a liquid. So melting solid becomes a liquid. And every solid is going to have a melting point. And we have a defined melting point for ice. The melting point for ice is 32 degrees Fahrenheit. Now we also have the Celsius scale, which is pretty easy to remember in Celsius. It's 0 degrees Celsius. But the melting point is when ice turns to water, and it's going to be a vice versa too. It'll be this freezing point down here as well. So melting is the process by which a solid becomes a liquid. It's the lowest temperature at which a substance begins to melt is called the melting point. Now 100% of this ice might not melt at 32 degrees. You probably have noticed that whenever you put a piece of ice out on a counter, the bottom of it you'll start gradually seeing a puddle of water, and you can actually see the ice and the water kind of in a state even though it's over 32 degrees. And of course it will eventually all melt, but the 32 degrees Fahrenheit is the point at which the substance begins to melt. Now 32 degrees melting point is actually a pretty low melting point. A pretty low melting point compared to all the substances that can be solids out there. Solid particles here are vibrating. I mean, even if it's a solid, the computer you may be looking at, the desk that you may be sitting at, that's still a solid, but it still has movement within inside it. That desk has molecules that are vibrating in there. There is constant motion, the scientists say, even in solid things. So whenever you get enough heat, that constant motion will make it expand, and they will eventually break those molecules apart. The hotter a solid gets, the more movement the particles have. And at the melting point, these vibrating particles break loose and slide past each other. Here we have ice. You have moving particles inside the ice, but they're not heated up enough to fall past each other, to break loose. And at 32 degrees is the point at which that starts to happen. You know, all of these changes of state have to do with heat. When you have a difference of temperature. So here we have this solid. You heat it and it makes it a liquid. You heat it some more and it makes it a liquid. And that's going to be true with more than just ice. You take all the solids in the world. If you give it enough heat, it will change it into a liquid. If you give that liquid enough heat, it will change it into vapor, change it into a gas. So changes of state is all about the melting or the rise of heat. The amount of heat, you put any amount of heat, you add heat, and that's when you start getting more likelihood for changes of state. And remember, a change of state is always what happens with the molecules. Here the molecules are tightly packed. Here they have broken apart, and they flow freely, and here they have literally become part of the air. They've really broken apart, and those molecules are way apart from each other. Now, some substances have a less defined melting point. We know that 32 degrees is a very predictable melting point. Whenever the weather gets to be 32 degrees, it's predictable that you can start seeing some ice out there. But many substances are not as defined how much heat you have to put to it to make it a change of state. And one of those examples is, of all things, chocolate. Chocolate tends to soften up in its pre-existing state before it finally melts. If you have some kind of chocolate bar here, oh, how am I going to draw a chocolate bar? That is one awful looking chocolate bar. But say you have this chocolate bar here and you make it hot. You heat it up. That chocolate bar at first does not look, oh, I am just messing up here. I'll get this right in just a second. What happens when you start heating a chocolate bar? It kind of tends to stay in its shape. Sure, it gets soft. Sure, you could put your fingers on it and probably get chocolate on your fingers. But it stays in its solid state longer. What happens if you heat up an ice cube? It goes down to solid pretty quickly. It does not tend to keep its shape and get soft. I mean, have you ever felt of a soft ice cube? No, you usually have a little liquidy on the outside of it, but still it's hard. So chocolate has a little less defined melting point. It's hard to point to one temperature at which you can have say that chocolate goes to the liquid form. Reading my notes is why I'm stalling here. So this prevents chocolate from melting at the same temperature every time. Now let's talk about freezing. Freezing, well, when we say, oh, we're freezing, it's synonymous with being very, very cold. And of course, it does mean when a liquid goes to a solid. Melting when solid goes to a liquid, freezing when liquid goes to a solid. But it's kind of a misleading term because even though ice solidifies at a freezing temperature or water solidifies at a freezing temperature, that's not going to be true with everything. For example, a candle. Candle wax solidifies at room temperature. And it's definitely not cold whenever candle wax solidifies, it's just room temperature. So these things that are freezing eventually attract each other. The molecules attract each other and start moving slow enough to bond together. So in all these processes, it's all a decline in heat. Less heat from the gas makes it to where the water forms, and less heat from the liquid makes it to where the solid forms. It's all about heat when it comes to changes of state. So the temperature at which you have freezing is, of course, the freezing point. For water, it is the same, 32 degrees, and it should be the same temperature or temperature range for pretty much every solid going to liquid and liquid going to solid. Now let's talk a little bit about evaporation. You know that water turning into the vapor is going to be called evaporation, and more specifically, it's going to be boiling. Boiling is the process at which liquid goes to a gas. Now boiling, we have a boiling point of water which is 212 degrees. And you may have noticed a pot of boiling water. The pot of boiling water has what that's in it? It's bubbles. The bubbles that are in that pot of boiling water is actually where you have the water that has turned into gas, and the gas is the bubble. So when that bubble goes up to the top of the pan, it is released out into the air. Released out into the air, and that is the gas that is coming out. That's how it's coming, that's where it's coming from liquid to the gas substance. Now, whenever you have liquid going to gas, you have all these molecules that are moving around. The liquid molecules are moving faster than it was in the solid. The ones that are the fastest to move are the first molecules that become the gas. And the higher temperature, the faster the molecules go and the quicker it evaporates. Now, under certain, well, let's see. We've had solid going to liquid. We've had liquid going to solid. That's melting and freezing. We've had liquid going to gas. What about gas going to liquid? Gas going to liquid is the process called condensation. When you have a gas going to liquid, that is condensation, and the point at which it condensates. Well, we'll talk a little bit more about condensation here in just a little bit. I have an example of sublimation. Now, sublimation is a little bit different from all these terms. There is a way liquid can go straight to gas. Not liquid. Did I just say liquid? Solid goes straight to gas. So a solid going straight to gas is going to be called sublimation. Now that doesn't happen very often. And I have an example on another page, but let me draw an arrow here. Sublimation is that process where a solid goes straight to gas. And here is an example. Right here we have the substance dry ice. You probably have heard of dry ice. This dry ice here has been put at room temperature in a bowl. And as you can see, the solid is going straight to gas. It starts to smoke, and that smoke is where you have all that vapor. It's gone straight to gas. So that's where it's solid, straight to gas is called sublimation. Don't forget it. Now we mentioned condensation earlier. Condensation is when you have gas going back to liquid. Now the best example, and for those of you who had me in 6th grade may remember, we used the example of this glass. Here we have cold glass. It's cold because you have cold liquid inside. And many times if you get a glass out of the refrigerator or a Coca-Cola bottle out of the refrigerator and set it out for a while, it's going to get that condensation on it. What happens, just as a reminder, all the air around it is warmer than the cold liquid inside. So what happens to this air that is just right outside touching the glass? The air that is right outside touching the glass is going to get colder. This air is going to get colder because you have cold liquid and a cold glass. So as a result, all the air around the gas, you have the water droplets form from the air. The cold air doesn't accept moisture like the warm air does. So as a result, all the moisture has to do something. It is dropped on the side of the glass. It has to do with a temperature change. Everything's change of state has to do with a change of temperature. So you go from hot air to cold air, and the colder it got, then you have more water here. Now what happens if you continue to get colder? This water in the liquid state will become ice. So it's all about temperature as far as the change of state. Hey, I hope you've learned a little bit about change of state. Don't forget to do the questions.